So a carpenter tosses a shingle off horizontally off an 8.8 meter high roof at 11 meters per second. So some key words there are horizontally, and of course the values that you're given. So let's first start by drawing a picture. So it's thrown horizontally. That means its initial velocity is completely in the x direction. Right? So the y component of the initial velocity is 0, and the x component is the entire velocity. Now, as this thing falls, it's going to move in a parabolic trajectory. At every stage along the way, Vy starts getting bigger. Vx stays the same because it's accelerating only in the y direction. And the total velocity, which is the combination of those two components, starts angling downward. It gets larger and it angles downward. Anyways, the question asks to find when the shingle lands, how far away from the house has it traveled horizontally. So let's put the origin right here underneath the launch point. It's an arbitrary choice, but it's a good one to put it right underneath where it's launched. And we are going to find, I guess right here, xf. So we want to see how far away the shingle has traveled. Start by listing out all your kinematic variables: x initial, x final, Vx initial, Vx final, Ax, Tx. Go over into the y dimension. Y initial, y final, Vy initial, Vy final, Ay, Ty. And then we also have this total V initial and the angle of the launch. So the initial velocity is it's 11 meters per second. And the launch angle is 0 degrees because it's launched horizontally. So what's the initial x position? Well, since the shingle is launched right above the origin, we can say that is 0. The final position, well, that's what we're looking for. The initial velocity in the x direction is v initial cosine of theta initial, which cosine of 0 is 1. So we can say that the initial velocity is just equal to the initial velocity in the x direction, which you know intuitively from reading the problem. And the final x velocity is just the same thing, and that is because the acceleration is 0. What is the time in the x direction? Well, we don't know, but we know the time in the x direction equals the time in the y direction. So the initial y position, well, that is the height of the building, which is 8.8 meters. And the final height is 0 because it comes down here and hits the ground. The initial velocity in the I direction is Vi sine of theta sub I, but sine of 0 is 0. So this all equals 0. And the final velocity in the y dimension, well, we don't know what that is. The acceleration is negative 9.8 meters per second squared, and again, ty equals tx, t equals unknown. So the first thing we have to think about is how do we find the distance as traveled? We don't know what this is, that's what we're looking for, and we don't know what the time is. And we know the final velocity, but since that's the same as the initial, that can cause some problems if we're looking at this third equation. Everything just, you end up with a situation where 0 equals 0. So we don't have enough information really. But we know that the limiting factor of how much time this spends in the air is the y dimension, because it eventually hits the ground in the y dimension. The ground stops this thing from traveling vertically. So maybe we can find the time in the y dimension and note that time is the crossover between the x and the y. So let's first find time. In the y dimension. So if you look at your equations, you see that this is a convenient one, Vy initial t plus 1/2 AYT squared. Well, conveniently, this term is 0 because the initial velocity in the y direction is 0. We also know the final position is 0. So, negative y initial equals 1/2 AYT squared. I can solve for t by multiplying each side by 2, dividing each side by AY. T squared equals negative y initial over negative 2y initial over AY. Take the square root of each side, so t equals plus or minus the square root of negative 2y initial over AY. This is going to have two solutions. You can put the numbers in. Let's do that. So plus or minus negative 2 times 8.8 meters over negative 9.8 meters per second squared. So the time equals plus or minus 1.34 seconds. Well, the negative solution isn't going to be relevant here because the negative solution means when does y equals 0, what it equals here, and if you back this parabola upwards, it equals 0 at some negative time point, negative 1.34 seconds. But none of this is relevant because, for one thing, the question doesn't ask about this area over here. Also, this trajectory doesn't exist. We're taking the parabola and we're starting the parabola at the peak and then continuing forward. So the math may give you a solution, but the physics says that solution is irrelevant. Positive 1.34 seconds. Now, find x final. Okay, well, x final minus x initial equals Vixt plus 1/2 AXT squared. We know the acceleration in the x direction is 0. We know we start at the origin, so x final equals Vixt, which is the same as saying Vi because the entire initial velocity is equal to the initial velocity in the x direction, times t, and I'm going to go ahead and throw in this in symbolic terms so you get used to seeing that, noting that only the positive solution is used. So x final equals V initial 11 meters per second times negative 2 times 8.8 meters over negative 9.8 meters per second squared. Its final then equals 14.7 meters.